Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I read the summary of your report on AutoGen, and I have some questions regarding the effectiveness of multi-agent conversation-based LLM systems compared to single-agent-based LLM applications. Can you explain why AutoGen is considered better in this regard?
AutoGen is considered better than single-agent-based LLM applications because it allows developers to build LLM applications via multiple agents that can converse with each other to accomplish tasks. This multi-agent conversation-based approach offers several advantages. Firstly, AutoGen allows for more complex and dynamic conversations. By enabling agents to interact with each other, AutoGen facilitates the development of applications with diverse conversation patterns. This flexibility allows for more natural and interactive conversations, enabling a wider range of use cases and improving the user experience. Secondly, AutoGen supports the integration of various resources and expertise. Agents in AutoGen can be based on LLMs, tools, humans, or even a combination of them. This means that developers can leverage the strengths of different agents to enhance the performance and capabilities of the overall system. By combining different resources, AutoGen enables more powerful and effective applications. Additionally, AutoGen provides a generic infrastructure that reduces development effort. Developers can use AutoGen to program flexible conversation patterns using both natural language and computer code. This versatility makes it easier to create complex LLM applications across different domains. Moreover, AutoGen offers a collection of multi-agent applications as examples, demonstrating its ability to support applications of various complexities and LLMs of various capabilities. Overall, AutoGen's multi-agent conversation-based approach allows for more dynamic, interactive, and powerful LLM applications. It provides flexibility, integration of resources, and reduces development effort, making it a better choice compared to single-agent-based LLM applications like ChatGPT.
Thank you for explaining the benefits of AutoGen's multi-agent conversation-based approach. While it does sound promising, I would like to delve deeper into the empirical studies that demonstrate the effectiveness of the framework. Can you provide more details about these studies and the specific example applications that were used to evaluate AutoGen?
Certainly. The report provides several empirical studies that demonstrate the effectiveness of AutoGen's multi-agent conversation-based approach. These studies aim to evaluate the performance and benefits of AutoGen compared to state-of-the-art approaches. One of the studies mentioned is A1, which focuses on a scenario where users interact with multiple AI agents to plan a trip. The evaluation of this scenario demonstrates that AutoGen outperforms other approaches in terms of both user satisfaction and task success rate. It shows that AutoGen enables more dynamic and interactive conversations among the agents, leading to a better user experience. Another study mentioned is A5, which involves a scenario where AI agents collaborate with humans to solve puzzles. This study shows that AutoGen allows for seamless integration of human participants into the multi-agent conversations. It demonstrates the effectiveness of AutoGen in enabling natural and interactive conversations between humans and AI agents. Furthermore, A6 is a study that explores the use of AutoGen in a scenario where AI agents assist users in shopping. The evaluation of this scenario shows that AutoGen enables efficient and effective communication between the agents and users. It demonstrates the ability of AutoGen to handle complex multi-turn conversations and provide personalized assistance to users. These empirical studies provide concrete evidence of the benefits and effectiveness of AutoGen's Multi-agent conversation-based approach. They showcase improved performance, reduced development code, decreased manual burden, and increased flexibility for developers. The specific example applications used for evaluation cover various domains such as trip planning, puzzle solving, and shopping assistance, demonstrating the versatility and applicability of AutoGen in different contexts.
Thank you for providing details on the empirical studies conducted to evaluate AutoGen. It's interesting to see the range of example applications used for assessment. However, I would like to further discuss the specific advantages of multi-agent conversation-based LLM systems over single-agent-based LLM applications. In your report, you mentioned that AutoGen's multi-agent approach allows for more dynamic and interactive conversations. Can you elaborate on how this dynamic and interactive nature is achieved and how it improves user experience compared to single-agent-based systems?
In our report, we discussed how AutoGen's multi-agent approach enables more dynamic and interactive conversations. Compared to single-agent-based systems, this is achieved through a few key mechanisms. Firstly, AutoGen allows for the creation of multi-agent conversations that follow a dynamic pattern instead of a fixed back-and-forth interaction. This means that the agents can engage with each other in a more fluid and natural manner, adapting their responses based on the context and the actions of other agents. This dynamic nature of the conversation enhances the user experience by creating a more engaging and interactive dialogue. Secondly, AutoGen supports collaborative and adversarial agent interactions. The agents in AutoGen can share information and knowledge, complementing each other's abilities and collectively arriving at better solutions. This collaborative aspect improves the user experience by providing more comprehensive and accurate responses. On the other hand, in certain scenarios, some agents may need to work in an adversarial manner. AutoGen facilitates controlled sharing of relevant information among different conversations, preventing distractions or hallucinations. This adversarial interaction can lead to more diverse and nuanced conversations, enhancing the user experience. Furthermore, AutoGen allows for the participation of humans in activities alongside multiple AI agents in a conversational manner. This means that users can actively engage with the agents, providing instructions, asking questions, and receiving real-time responses from multiple perspectives. This participatory nature of the conversation makes the user experience more immersive and interactive. Overall, AutoGen's multi-agent approach enhances the user experience by enabling dynamic and interactive conversations. The fluid nature of the dialogue, the collaborative and adversarial interactions among agents, and the inclusion of human participation all contribute to a more engaging, comprehensive, and personalized conversation experience compared to single-agent-based systems.
Thank you for explaining how AutoGen's multi-agent approach achieves dynamic and interactive conversations. While this approach does seem to enhance user experience in terms of engagement and comprehensiveness, I have a concern regarding the complexity of managing multiple agents. In multi-agent conversation-based systems like AutoGen, how does one ensure coherence and consistency in the responses provided by different agents? And how does this compare to the control and consistency achieved in single-agent-based LLM applications?
In multi-agent conversation-based systems like AutoGen, coherence and consistency in the responses provided by different agents are ensured through a coordinated communication process. AutoGen allows developers to define agent interaction behaviors using natural language or computer code, which enables the system to maintain coherence and consistency. To achieve coherence, AutoGen uses a predefined order of conversation where agents take turns to speak based on a dynamic selection process. This ensures that each agent responds in a logical and meaningful way to the previous agent's message. The conversation flow is designed to follow a coherent structure, similar to how a group of individuals would converse in a real-life scenario. AutoGen also facilitates consistency in responses by allowing developers to define guidelines and constraints for agents' behavior. These guidelines can include rules for generating responses, adherence to a specific tone or style, and consistency in providing accurate information. By programming these guidelines into the system, AutoGen ensures that each agent's response aligns with the overall goals and intentions of the conversation. In comparison, single-agent-based LLM applications like ChatGPT lack the explicit coordination and communication between multiple agents. While a single agent can generate coherent and consistent responses based on its training data, it may struggle to maintain coherence in a multi-turn conversation. Single-agent-based applications do not have the ability to dynamically select the next speaker or consider the context provided by other agents in the conversation. AutoGen's multi-agent conversation-based approach enables a more interactive and dynamic conversation, allowing for a higher degree of coherence and consistency among the agent's responses. By coordinating the responses of multiple agents and providing guidelines for their behavior, AutoGen ensures that the conversation remains coherent and consistent, leading to a more effective and natural dialogue experience.
Thank you for explaining how AutoGen ensures coherence and consistency in multi-agent conversations. The coordinated communication process and the ability to define guidelines for agent behavior indeed seem to address my concern. However, I would like to explore the scalability of AutoGen's multi-agent approach. In your report, you mentioned that AutoGen serves as a generic framework for building diverse applications of various complexities and LLM capacities. Could you elaborate on how AutoGen handles the scalability and performance of multi-agent conversations, especially in scenarios with a large number of agents or complex interactions?